843.
Alright, we got the hunk of steel in the mail. I bought, I couldn't get anything smaller than 6 inches. And the funny thing is, I was going to get 4 inches. Which, excuse me, Mike, let me borrow it.
Okay.
And just so happens, this guy had 3 3/4, which is exactly what we need. Let me see if I can lift it up here one hand. Okay. And that 3 3/4 is going to be perfect, and we won't have to cut that down. But we are going to have to face it off and drill the holes for the valves and the exhaust pipe and everything. And I mean, it's going to be a lot of work. And I asked Mike, instead of using these little machines, this is what we build all our engines on, is this little tiny mill. And that piece would fit in there, just barely, and we'd do it, but it would, it's a struggle for it. I mean, it's only a small lathe. And then we got this mill here. And we did all our engines with it, but Mike has a full size at his house. And I asked him if he would mind taking us home and facing it off and drilling everything we need. And he said, nah, no problem. So, let me put that down there. That weighs, what? Christ, that weighs about 30 pounds, 35 pounds. But anyway, we're all cut up here on the head, and it's all ready to go. So Mike is laying out right now where everything is.
Just visualizing it here. 1, 2, 3. So, I'm just trying to, we're going to lay out the intake and the exhaust ports, because once I bring this out, the operation is going to go something like this. So I'm going to cut it to the rough thickness, face both sides, put it on the rotary table on the mill. I'm going to mill out a pocket for our combustion chamber, and then drill the valve guide, drill the port, and then make the valve seat for both valves, all in one operation. You know, not one operation, but with the head bolt, with the head
without removing
it. Exactly, the same fixture, and then from there, we're gonna have to drill in the side for the ports.
Okay.
So, and then once that's all said and done, while it's in the rotary table, I might as well drill the head bolt holes as well. So I'm gonna lay those out, all, you know, while it's clamped at one time. So I should be able to do that without too much difficulty.
Right.
And once that's all done, we'll have to figure out how we're going to attach the exhaust and the intake, if it's going to be like a threaded hole or a flange or what.
Right.
So 3 3/4 is our diameter, so the radius is what? Going to be 1 7/8. So
what we're going to do tonight is Mike is basically going to lay out on paper where everything's going to go.
Right. I'll take this with me. A little bit of a blueprint. We usually don't follow blueprints, but in this case, since I'm going to be working on it at my house, it might be easier just to design it now, follow a blueprint, because I'm not going to have the engine and all this other stuff with me. So, you know.
And I asked him to film it because, you know, when he has it at his house, he's going to work on it when he can. He's not going to say, okay, I'll be working on Saturday at 2 o'clock.
Right.
You know, he may do a half hour after work and an hour the next day, and then maybe 8 hours on a Saturday.
Exactly. But so I'll try to.
He's going to try to get us some film.
Definitely get you a film, because that'll be a little bit interesting, you know.
Yeah. Even if he just sets it up while the machine is running, he doesn't even have to narrate. You know, you guys pretty much know what's going on. But I'm going to see if while he's doing it, you know, if he's going to be there on a Saturday or sometime where I have time to get over there, I'll get over and maybe follow him a little bit. So, all right, let us figure out where we're going to put all this stuff, and then with all these reflections, Mike, I don't know how much we can see.
Now, can you see?
Yeah, we can see now. He's going to start with a circle, and then we'll just lay everything out. So, all right, I'll get back with you when we got something down on paper here. All right, looks like Mike has a good portion of that head drawn out there, and you also have where the push rod's going, huh?
Yeah, well, that's just to visualize where they're going to be, right? Because we know that the rockers are going to have to come in like this. They're going to be a bit of an angle coming in there.
A little askew.
Right.
That's okay.
It won't look bad. It'll be symmetrical, you know?
I mean, I've seen that on many engines.
Yeah, and then got our head bolt holes lined out. valve here, valve here. This is the outline of our combustion chamber right here. So, and this is the outer diameter of the head here.
Right.
So
now we're just trying to figure out where we want the intake and the exhaust.
Right. So the way you're looking at it, this is the intake, this is the exhaust. So we're thinking of having the intake come out on this side. So we'd have a carburetor coming out here and an exhaust coming out here. And the spark plug, I'm not quite sure where that's going to go yet. It would look nice if it was directly opposite of the push rods or the rockers, but we might run into some problems as far as where the ports are run and where this head bolt ends up being.
Right.
So the next thing I'm going to do right now is, this is a top view looking down. I'm going to sketch a side view similar to what I did a couple pages back. Sketch the side view with the ports drawn in and the location of the bolt hole, and see if we can visualize where that's gonna lie. If we're gonna have enough room to put the spark plug where we want it, which is right in here, or if we're gonna have to tuck it in. Really, it's got to go here. It's got to go on either end of the valves. It can't go. It can't go here because it's going to be blocking a port, or it's going to be obscuring a valve.
I think we might be able to get in between the
rockers,
the push rods.
Because you can see. Look here. Look at this head here.
This one here.
You can see the spark plug's either got to be here between the valves or here. And in this case, they've got the push rod there. You know, you can't have the spark plug coming in over here or here. It's got to be two places.
Right.
Or the other option is to have the combustion chamber tall enough so that we can actually bring the spark plug in, you know,
through the side,
directly through the side at a 90-degree angle to the bore. So we could
if
do that.
If we can avoid that, we will. But
yeah, I'd like to.
Or maybe we can get a little spark plug, like the size of a spark plug off of a weed whacker or smaller.
Yeah, well, what are they? 14mm thread usually. You know, they do make smaller ones.
Yeah.
So I think they make a 7. But I'm not.
Yeah.
I haven't seen that.
We'll figure it out.
Actually, you know what? We probably have a 7 laying around from that. Remember that 4-cycle weed whacker we took apart? I bet you that had a 7mm spark plug in it. Probably around here somewhere. We got plans.
Well, you find that and work on that. What I'm going to do here is, I'm just going to make a template of this head, so when Mike goes home, he don't call me and say, what was the measurement between this and that? And that's where things start going wrong. So what I'm going to do is, I'm going to put a piece of paper on here and make a template, and he'll have the exact dimensions right here. Alright, while Mike's sticking around with that, I'm going to mess with this, and I'll probably make him a couple here, since it's got a wooden thing in the middle here, just to hold it in place so it don't move. I'm going to put these thumbtacks in there, and then just take a pencil, and when you run it over the side, there you go, you can actually see where it's coming up. And I'll show you where all the holes are. There's some holes over here, you can feel them. And it'll actually just make it darker where the holes are at. Some guys actually put their finger on it and go around like this, and that'll accomplish the same thing. What else I use? My dirt, what else? Ash and...
Oh, right, like charcoal.
Yeah, just dirt from the ground. So you can actually see how it's coming out just by rubbing my finger on it. So what I'm going to do is I think I'll use that method. I'll just lay some more lead down, and then I'll rub that. Alright, don't go away, guys. Alright, I laid some lead down here and just pretty much smeared it around here. Like right here, looks a little light. Give Mike a little something a little darker to go by. Marked out where his rockers are. And there you go. You can take that home with him, and we'll know exactly where everything is at. Alright, we get you off. Let me take you over here. Let me show you what happened since you were gone. Because over there he brought my dinner. Everybody thinks he just does nothing. He sits around doing nothing. But there he is. Alright, let's eat, and then we'll get back to business. Alright, I see Mike over here taking apart one of our other engines. What's the problem, Mike?
There's no problem, really. I'm laying out I'm trying to lay out in full scale just a diagram of how the cylinder head's going to be from a side view. So, you know, I've got the valve here. This line represents where the top of the spring would be. So what I have to figure out now is how compressed this, actually this is the intake, how compressed the spring is when the valve is closed. You know what I mean? Because right now the valve, the spring is not retained by anything, so it's just free. But in reality, when the engine's assembled and the valve is closed, there's got to be a certain amount of tension on the spring to holding the valve up or closed. So I just pulled over this other 5S here, and I'm just going to take a rough measurement of this intake valve as it is compressed. Because here's the same spring uncompressed. You can see it's the full height of the valve chest there, the valve box. Yeah. So in reality, it looks like it's about 3/8 of an inch compressed. I'll have to measure that. Right. And I'll do the same for the exhaust. I'll roll the engine over so the intake is open and measure the exhaust as it's fully closed. So that's the plan.
All right, good deal, buddy. I was just curious.
No worries.
All right. All right. Mike's all finished here. He's got all his measurements and everything. He's going to take us home, and like I say, he's going to work on this on his lathe and mill. So since we really don't have anything to show you, what I wanted to show you was I got this in the mail, and this here is a coil from one of my subscribers, a long-time subscriber, probably about a 6-year subscriber, and he always commented and stuff. And I didn't even know his dad makes these coils, and they're almost identical to the 100-year-old coils that we use. Here's the buzz coils that we use, and if you see all the writing on these, you know, this one needs adjustment, it's good, it's bad, you know what I mean? I always had trouble with these, and he sent me this. He didn't want to shout out, didn't want anything, didn't want to promote anything. He's just a good subscriber that asked me if I wanted to try out one of his things there, and this is what it is. So you want to hook it up, Mike? And oh yeah, his name is Tristan Scott, and his dad owns this company, DX Ignition, and they cater to the Fairmount little train cars.
Yeah, the speeders. The railway speeders.
Yeah, the rail speeders.
Little 2-stroke engines in them.
Right, exactly. Matter of fact, they even make one. They make a bigger ignition for the 2-stroke.
Yeah.
But anyway, let's hook this up and show what this thing will do.
All right.
All right. There's really not much to hooking it up. Mike is hooking it up now to a spark plug. But what it comes with is it comes with a spark plug, and it just hooks right to the top. And then I just happen to have an old battery here, an old Harley Davidson battery. You can hook it up to there. But it also comes with 2 extra things in case you want to like put a cloth on there or something. So
yeah,
let me get some jumper cables and we'll continue on.
I'm ready.
All right, Mike has this hooked up, and the size of these things is just about identical to the Model A buzz coil. Mine ain't sitting flat because I have a clip on there, but
yeah, the size is.
They're identical in size.
That'll slip right in your coil box if you have a Ford tractor or a Model A or a Model T or whatever use these coils pretty much. What's
nice about it is it's smaller than these other ones. This is a Detroit coil, and it's about what, a third the size?
Yeah.
Yeah. So that's cool. But anyway, we tried it before, and I'm really impressed with it. And Mike likes it too. I mean, the insides are just. What would you say, solid state, Mike?
It is, yeah. It is solid state. Yeah. There's like an automotive type coil pack in there, right. Like a generic thing. And then there's a circuit that I guess he made up. I guess it's an oscillator that, takes the DC input and I guess pulses a DC output to the coil. Right. And that, whatever.
It gives you what you need with no moving parts.
Exactly.
And you can either buy it like this, or he also sells a cheaper version. They call it the Express, the DS Express, and it's just the internals. If you don't want this box, that's a good-looking box. Mm-hmm. But anyway, let's give it a try, Mike. Okay. We got the battery hooked up, and it's simple. You just hook the black and red terminals up, and they.
Yeah, exactly. There's it's very similar to a buzz coil in that you have it's just a positive and negative input, and then a high voltage output, which is referenced to negative. So yeah, it works.
But with this, we got a spark plug hooked up to it. And we got this thing gapped, like almost a 1/4 inch. Yeah, 3/16 1/4 inch. So watch this lightning bolt it throws. It's incredible. Look at that.
And I think it says specifically in the instructions that you can throw that spark for as long as you want. You know, with a buzz coil, you really don't want to leave them buzzing because you risk burning them out.
Right, you got contacts. Here you don't have contacts. But anyway, you don't need that. I mean, you just put a very 30,000 sketch.
Yeah, sure.
Yeah. But I'm impressed with it. So anybody looking for these, I would highly recommend them. And here's the guy's name. That's the name of the company. And here's his card. Let me see if I can zoom in on this and hope it focuses. I think I'm going to have trouble with the glare. Okay. I'll get at it from the angle here. Okay, so there's his guy's email, his phone number, his name, and everything. So go check it out. He's got a really good website. And I appreciate him sending this. And like I say, he didn't want me to review this or even mention his name. But I'm going to leave a link to the company that they run here, and also to Tristan Scott. He's only got like 66 subs, but he's got a good channel. He doesn't put up many videos, maybe 2-3 a year, but it's a good channel. So, like I say, go check him out. And Tristan and Brett, I appreciate you sending this. And anybody asks me about them, you know, they come highly recommended from me and Mike, right?
Oh yeah.
All right.
Yeah,
so like I say, we just figured we'd throw this in as a filler because we're.
Yeah, I was just reading here in the instructions. They say that you don't need the condenser across the timer if it's a multi-cylinder engine, or even if it's not. You don't need the condenser across the timer contacts like you do on the buzz coil. I guess because this is solid state, like we said, that whereas the buzz coil's got a primary side coil which is going to have some inductance, which is going to create arcing across the points if you don't have that condenser. So that's nice that you know there's draws very little current, I would imagine, and there's no like inductive kick to it. So when you break that circuit, it's not going to arc. So that's really nice. Let's see.
Yeah.
There's probably nothing even noticeable if I just. Yeah, very, very slight. Very slight, so. Yeah, pretty neat.
Yeah, I'm not sure. Can you see what? I think it comes with a 1-year warranty.
Does it?
1-year guarantee. Is it saying there?
I don't think I saw anything about warranty. It might be on the website.
Yeah, I think it's seen on our website. But anyway, check out the website. I mean, like I said, he's got a really good website. So thanks again, and you guys go over and check him out, and also check out Tristan's channel there, and thank him for sending us, because he knows we needed something for what we do with our engine. He knew we needed something for this little engine we're building. So, all right, enough for this, huh? Say goodbye, fellas.
So long.
Alright, tubes.
Daddy.
Later.
All right, guys. We'll see you next time we see you. Maybe over Mike's house.
Could be.
All right. See you later.